Logistics is a term with military origin, which refers to the supply and distribution of goods. However, logistics is as old as humanity itself. It has been present in every written moment of history and has been decisive in the evolution of humanity. Logistics allows us to have a globalized, connected, and fast world. In the evolution of logistics until 2022, companies have begun to understand that logistics gives their products and processes a competitive advantage, which is the key to their growth and positioning in a competitive market. The consumer values quality, price, and service to choose their logistics service provider. In this project, we work with TCC, a company that aims to provide solutions that integrate the build capacities of its businesses, being analyzed throughout the supply chain. This project focuses on finding a way to identify customers who are likely to leave the company, that is, the rate of abandonment. This allows companies to act quickly to retain the customers. For this, we use the churn analysis and the data of the company's clients in Colombia between January 2021 and April 2022. The data includes 3,132 client accounts, which have the tax identification number as its key. This information is collected when the guide is generated and the shipment information is filled out, such as city of origin, city of destination, price, number of units, among others. In our analysis, these data were crossed with other databases, such as the Super Sociedades database, to determine the size of the company. In addition, the operations center was crossed with the names of the departments to create a geographic heat map. With the initial information, some cleaning, selection, and transformation processes were carried out to guarantee an adequate development of the model. Some Python libraries were used, such as NumPy, Pandas, Seaborn, Matplotlib, Geopandas, Branca, among others. Now let's look at how the churn model works. In this case, churn is defined as customers who went inactive for more than 1 month. For this model, we use 11 variables, composed of 8 categorical variables and 3 numerical variables. Before implementing the model, a transformation of the variables is made. The categorical variables are coded as dummy variables, and with the numerical variables, a standardization process is carried out. Also, with the missing data, a data imputation process is carried out using the median of the total data. At the end of the data transformation, we have 217 variables that are the ones that will fit the model. Once the variables are processed, the model creation process begins. The data is divided into 3 sets. The training set is used to train the model, the validation set is used to calibrate the model, and the testing set is used to make the predictions. In this project, 4 different models were tested: random forest, decision tree classifier, rich classifier, and logistic regression model. At the end of the test, the logistic regression model had the best results. The logistic regression model predicts, based on the 217 variables, who are more likely to be closer to 1, companies with a high churn probability, or closer to 0. Now let's look at how the application works. The application was developed in Dash, based on Python and the libraries used during Data Science for All. The first option of the application, called What is a Churn Analysis, includes a portion of theory for the user, in which it is explained what is a churn model, the importance of customer churn prediction, and some challenge of building an effective churn model. The next option includes some descriptive statistics of the information provided by TCC, which includes approximately 10 million data. The first option includes a view of remittances by sector, where the user can see some concentration in sectors such as trade, logistics, and textiles. We also focus on analyzing the geographic composition of the origin of remittances according to the center of operations, and through some data adaptation work, we generate a geographic heat map which is very useful for understanding customer behavior and their geographic location. Also, the user has a graph with remittances by customer, where it is evident a concentration on some Pareto customers. In the exploratory data analysis, we grouped some variables by economic sector, by date of creation, where we were able to observe a seasonal behavior associated with market trends and the dates of economic reactivation, such as Christmas, days without IVA, among others. In the third option, the application have a description of our era, in which the user is told where the analysis carried out with information, how the churn variable was defined, how the churn model was selected, and how it was applied. Finally, the application has the churn model, where it's necessary an CSV file with customer information to apply the model. In this case, we have an example file with 49 companies with their respective information. On this file, we apply the model that was trained and recorded, and the result is a bar graph with the churn value per client. The churn probability is higher if the value is close to 1. This bar chart allows the user to visually identify companies with a churn alert. In yellow, those companies with a churn value greater than 0.5 are identified, and in blue, those companies with a value lower than this. Companies that apparently don't have bars on the chart have a very low churn value, close to 0. We hope that this application will allow TSC to react opportunely to customer churn and increase productivity and sales. This application was made with an important research work on churn models, the learning obtained in data science for all lessons, and the expertise of the team. Thank you.